It's clear that within coffee there are a number of priorities, and the coffee industry or national stakeholders are going to be interested in those species that have some financial potential, or indeed a financial, or indeed a crop species already. So those will be the priorities: Arabica, Robusta, Eugenioides, the species that are used in coffee production. So those will probably be okay because people want to preserve them. But I think we're going to have to be realistic and say, actually, we're only going to be able to save 50% of the genetic of the species that we presently know, and that's just a realistic viewpoint. So we're all interested in supply, we're interested in taste profiles, we're interested in sustainability. What is the value of those wild Arabica forests in Ethiopia? I entered the coffee research world by researching Madagascan coffee species. That started in '97 and pretty much continues to this day. So I've made about 15 expeditions to Madagascar, going to some of the remotest parts of the island just to look for coffee species. I had a botanical career before I worked on coffee, and so I knew the landscape, the plant diversity landscape. And even with that background, after a few years in Madagascar, I was totally blown away by the things that we found. The number of new species, but also the diversity, the weirdness of these things. So winged fruited coffees, hairy coffees, dry adapted coffees, the world's smallest coffee cherry, the world's largest coffee cherry, all these superlatives in one island. It was amazing. So after 15 odd years of research, we added about 25 new species, so new species to science, to coffee. And that work still continues, and we've got about at least 10 more species to add to that. Arabica is a hybrid. It has two parents, Coffea robusta, or actually the Latin name is Coffea canephora, and Coffea eugenioides, and that has a common name, Nandi coffee. And those two species met in a forest, possibly in South Sudan or in the Congo. There was a union, a hybridization event, and that gave rise to Arabica. And it appears, from the genetic data, that happened only once. Just one unique event. Some people say that Arabica's 600,000 years old. Other research teams say it could be as young as 20,000 years old. But it's certainly a very recent species within coffee. If you look at the genetic data, and some of it's published, some of it's not, what you see is the diversity in those forests is enormous. Absolutely enormous. Each forest area has its own distinct range of genetic variation, but also there's good evidence to show that those populations have mixed. There's some gene exchange between those populations. The other key thing is there are lots of seedlings, and those seedlings supply standing genetic variation, and that standing variation enables adaptation, and that is very important. It's very clear when you visit the forests of Ethiopia, the natural coffee forest, the home of indigenous Arabica coffee. There's a huge amount of genetic diversity. If you compare that with cultivated Arabica, the genetic diversity is very narrow. And that's because when it came out of Ethiopia via the Yemen, it did so from the 1500s onwards through to the sort of 1800s. And the methods of dispersing plants around the world, say from Europe to South America or to Southeast Asia, was via wooden ships, sailing boats. And very few plants survive those journeys. So the plantations of South America, it's alleged, are based on one individual plant. So with one individual plant, you don't have a lot of genetic diversity. Even dispersals out of Yemen to Asia during the 1600s were from a handful of plants. I think I've seen somewhere it's written 6 seeds. So very, very limited genetic stock. So in my talk, what I proposed the notion that the genetic diversity in plantations around the world was less than 1% compared to that present in the wild coffee forests of Ethiopia and South Sudan. One of the questions we really wanted to answer when we started to understand how many coffee species there were was, what's the likelihood of extinction? Are they threatened? Are they common? So we did some analysis using distribution data, and what we found is that of the 100 species we examined, nearly 70% have some threat category, some endanger status. And 10% of those are critically endangered. And what that means is that they could become extinct within 10 years. And during the period that I've been working on coffee, we have seen at least one extinction. And there are certain other species that may have become extinct 100, 200 years ago. So extinction is a real possibility, and it certainly is a reality for some species. Preserving species is a costly business. You can't just conserve one plant, you have to conserve populations. The best way of conserving genetic diversity or species is to conserve it in its natural environment, so-called in situ conservation. But we know that doing that is a very cost-heavy business. And it's difficult if there's no immediate financial incentive to a country or to an organisation interested in preserving those genetic resources. Some coffee species already occur in protected areas, so they're already within national parks, so they have some degree of protection, but many simply don't. And I gave the example of a coffee species in Madagascar, which is existing in a forest no bigger than the Symposium room. So that could be extinct within 2, 5, 10 years, I don't know.